Hi everybody and welcome along to Higher Diploma in Computer Science, Programming Fundamentals. We're in week 6. You've just had a reading week. Hopefully you're all caught up and recovered after your week of no new materials. Thank you very much for getting your assignments in for programming, and I know you're being very busy working on an assignment for Eamon de Lister as well. So let's just take a recap of what we've been doing in Programming Fundamentals, because it's been a while since we were speaking to you. The first 3 weeks, we got you the basics of programming so that we could learn how to write simple programs. So we started off with learning about just how to run a very simple Hello World programming, drawing a simple drawing, static drawing, and then we moved on to creating animated drawings. We started including if statements and loops. We have variables, different data types, printing out to the console. After that, we got involved with methods or functions, and we needed to do that because we needed to work with pieces of text, and that required us to work with something called a string object. We wanted to be able to take in values from the end user. So that required us to use something called the JOption pane, which is part of the Java Swing classes. So all of the materials that we covered in the first 3 weeks then set us up for your first assignment, which we're now correcting, and we will have back to you by the end of this week. Okay, so we'll have some feedback for you. Well, actually very detailed feedback for you by the end of the week. We then moved on in week 4 to classes. So having just done what we needed to get done in order to be able to implement the assignment, we looked into more detail about classes, the string methods, objects, behaviors, attributes, and we looked at something called a spot class, which was a class we defined ourselves for managing drawing a circle and displaying it on the screen. This brought us on to overloading and encapsulation. We talked about getters and setters, otherwise known as access modifiers and access mutators. And then we combined our objects with arrays so that we could create an array of objects. And week 5 was primarily about getting comfortable with arrays. So we're in week 6 now, and this week is all about looking at a game. We're going to look at many iterations of the game, and the game we're looking at is the game of Pong, which is basically a ball going over and back on a screen. And there are so many micro elements to this game that are common in most games that by looking at a simple game we can find out how to solve those simple problems, but then also apply them in our own games. So by the end of this week you will have analysed a game, you will have gone through many different iterations of Pong, and you will be ready to create your own game, which is assignment 2. Just going to go back into a little bit more detail on last week. So the JOption pane was our mechanism for taking in or outputting to the user. So we saw the message dialog, the input dialog, and the confirm dialog. And then we got into arrays. So we said arrays were structures that can store many values of the same type. They enable us to store input data efficiently, and we can use loops with arrays. We said arrays can store any data type, and we looked at 3 in particular. We looked at int, which is a primitive data type. We looked at string, which is an object built into Java. And then we looked at an object that we create ourselves, and that was spot. Important things to remember about arrays: zero-based, meaning the first index is 0, and the last index is the size of the array minus 1. When we're declaring an array, we saw that we could take our data type and our variable name, and what makes it an array declaration was this bit here. So the square brackets we associate with using arrays. So when we declare an array, it's initially got a null value, and this was a special value that we had to be mindful of. And when we wanted to then initialize the array, we had to add some additional code, and that was the new keyword followed by the size of the array inside square brackets. So this creates an array. In this example here, we're saying create a variable called array name, initialize it to be a new array of integers of size 4, indexed from 0 to 3. Now we can combine the previous two statements into a single line and do the array declaration and array initialization in a single step. And that's an example. One of the questions that came up on the forum, so we thought we'd highlight some issues, was the question around the square brackets. So you can have your square brackets either after the variable name, as we see on the left hand side here. All of the variables, spots, words, characters, small numbers, numbers, we've got square brackets after the variable name, but you can also include them on the before the variable name after the data type. So we're seeing square brackets before the variable names on the right hand side. You can use either, and that was one of the many questions that we got from you on Slack. So this week, what are we going to be doing? Well, we're going to be building the game of Pong. Why? Because most games solve similar problems and have a lot of different issues or sub-problems that are common to each game. And by the end of the week, if you go through all the iterations, you're going to be able to build your own game. You're going to be able to apply what you pick up in different scenarios. And why is that important? Well, you've got an assignment 2 starting next week. So this is going to get you ready for that. Okay. So how are we going to do that? Well, let's take a look. So I want to start by doing a demo of the game of Pong. I'm going to do it here, and let's just take a look. So I'm using multiple screens, so I've just got to move a few things around here. Okay, so in this game it's asking us for the number of games I'd like to play, so I'm going to say 2. My name, and it's saying a maximum of 6 characters, so I'm going to put in more than 6 so you can see what happens. And this is the game of Pong. So I'm controlling a bat on the right hand side, and every time the ball hits off the bat I get a score, and if I miss the ball I lose a life. So here it's told me, game over, you scored 52, would you like to play the next game in your tournament? Let's say yes. So here we go. So I'm just going to leave this play out. And in this example, in game 2, it said my score was 1 because I only hit it once. And I lost all the remaining lives, but I've got some analysis or statistics at the end telling me column D, so it cut off the column Dunphy, your tournament is over. Number of games played is 2. Scores for column D, score 1 was 52, score 2 was 1, highest score was 52, lowest score 1, the average score 26. Okay. So that's the game of Pong. So what I'd like you to do now is I'm going to share a file with you on Slack. Actually, before I do, I want to know who I'm dealing with. So can everybody please just say hello if you're taking the class live today? I've said hi everyone, programming class starting in 20 minutes. Can you please just reply to that thread in Slack so I know who I'm dealing with? Okay, thanks for your replies. And if you are taking the class and are a little bit nervous about taking part, I would really encourage you to take part. There's no harm here. We're hiding your identity. So I would really encourage you please to take part and get used to posting on the forums, because we've got an announcement later in the class today which might upset some of you. Okay, so more on that later. Okay, so yeah, we've got a good response there. So now that we know who's with us, what I'm going to do is I'm going to share this file It's a zip file. You're all comfortable with using zip files at this stage. And what I'm giving you are the solutions to all the different versions of Pong that we're going to be looking at, including all of the ones from today. So what I'd like you to do is to take the zip file that I've just given you, unzip it, and the version that I was running a moment ago was version 8. So if you, when you unzip it, you'll see lots of subfolders, like I've got here. And here's version 8. And what you want to double click on is the Pong game version 8. Okay, and when you double click on it, it's going to open up in your processing environment. And then you can press run to try out the program. And you can see how the program runs. Okay. So I'll just give you a couple of moments to try that out. And I want you to pay attention to what's happening in the game, because I'm going to ask you a question in a moment. Okay. So try it out and try and observe all the different elements that are happening in this game. Okay, I think you should be good at that. You should have been able to expand that zip file, download it, and also try out running the program. You've also seen me run it on screen if you had any trouble there. Don't forget, during class at any stage, if you have any questions, please post your questions onto the Slack programming channel rather than direct messages if possible. And of course, if you see a question before I do and you can answer it, feel free to reply in a thread to answer the question. Okay, so now that you've tried that out, let's get you all to open up a tab and go to Socrative. And we've got a quiz that we're going to work through today. And I've just opened up the first question for you, which is: the game is made up of lots of features and problems to be solved. List at least one game or one part of the game that we need to solve. So the game is made up of lots of small features and problems to be solved. List at least one part of the game that we need to solve. Just waiting on a couple of more. If you can post your answers. So let's start taking a look. So we're going to have to handle the ball. Yep, so the ball has to move around, correct? And it also bounces, so we'll be handling that. Creating the ball class, defining instance variables and methods for ball objects, correct? We also have to handle the paddle, very good. Most of you have answered at this stage, so I'm going to show all the answers. Let's have a scan through these. You have to keep track of the number of lives that are lost. The ball must change direction when it's moving a moving target on the x-axis. That's correct. Paddle collision detection. So when the ball hits the paddle, yeah, we have to worry about that. That's called collision detection. I have no paddle. If you run the program and move the mouse over the screen, you should see a paddle. If not, we'll take a look at it during the break. Ball needs to bounce off the wall. Ball needs to bounce off the paddle, and scores need to be recorded. Yep, scoring there is a new addition. Handling the paddle, creating the ball class. Yep. So most of you come up with the ball, the paddle, collision detection, scoring, and lives. There's 5. Okay, so that's great. Now there are actually more elements. We're going to take a look at those now as we go through our slides. So thanks for your answers on that. Okay, so we've shared out the zip file, we've had a look at the quiz. Now let's go through and pick out maybe some of the things that you might have missed. The first thing that happened in the game was the player has to decide the number of games that you play. So it's not just the bit that's running, it's the bit before and after the game that make it a game. So we have to concern ourselves about the number of games in a tournament. So the concept of a tournament. And we saw that when we took in this number here. Welcome to the Pong tournament. Please enter the number of games you'd like to play. You also have to enter the player name. And we said if it was less than 6 characters, then Pong truncates the string. We're only allowing 6 characters. Some of you might remember the old arcade machines from your misspent youth. If you did, you remember you could only enter 3 characters in your highest score on a game. So it's just to we're including that in the game here just for nostalgia. Okay, we also have the notion of the paddle and the ball, and I think this was the most common answer that we got from you. So the paddle is the rectangle and the ball is the spot or circle. When the ball is hit by the paddle, the score is increased by 1. When the paddle misses the ball, a life is lost. So we had scoring and lives. The number of lives in a game is 3. Now when a game ends, there's no games left to play in the tournament. So the score is displayed and the players asked if they want to continue with the tournament. So again, this is something that most people missed. When the game is over, what happens next? You need to continue because the game doesn't just crash out usually. So we have this concept of a yes/no dialog box. Do you want to continue, yes or no? Now, if the player continues with the tournament, the game's score is stored in an array and a new game is started. So we have the notion of the number of lives lost goes to 0 and the score goes to 0. So we're resetting the variables every time we start a new game. So it's not just at the start of the program, but every time you start a new game, you need to reset the variables. When a game ends and there's no more games are left in the tournament, for each game in the tournament you display the player's name and the score. And you also display the tournament statistics, the highest, the lowest and the average score. And we saw that with the dialog box like here. So the tournament's over, number of games played 3. We have 3 different scores for Donald, the highest score, lowest score and average score. So these statistics we have to store variables to be able to display these statistics at the very end. So the Pong game, if we start thinking about it in terms of classes and objects, we have the Pong game itself, we have a ball class, a paddle class, and a player class. Pong game handles setup and draw, starts the game, handles the player input, manages the collision detection between the ball and paddle, and then ends the game and outputs the player stats. The ball class is focused on just the elements to do with the ball, and that includes controls the location, size and speed of the ball, then it updates the ball position and displays the ball. Likewise for the paddle, we control the location and size of the paddle in the paddle class. It updates the paddle location and it displays the paddle. We also have a player class, and the player class stores the player name and their score for each game in the tournament. It calculates the statistics for games in the tournament for that player. Okay, so we are going to have, by the end of 9 iterations, we're going to have 4 different tabs in our processing environment. We're going to have one tab for Pong game, and then we'll have a tab for ball, a tab for paddle, and a tab for player. So what I've done here is I've showing the 9 different versions of the game, and each version gets slightly more complicated or implements new functionality. That's probably the easiest thing to say. It just each version is new functionality primarily. In today's class, we're hoping to cover 5 versions. We may only get to 4, and then in the next class, you will work through the remaining versions. Okay, so we're going to start off with the first part of our game, which is the ball is moving over and back on the screen. Version 1 is concerned with the ball moving from left to right on the screen. There's one further complication. It can bounce off the top or the bottom of the screen, so we're going to have to handle that as well. Okay, so demo of Pong game version 1. Okay, so again, I would encourage you to open up version 1 on your own system. Open up version 1 folder and run Pong game version 1 right now, please. So I'm doing it here. Here's our folder of zip files. We've got Pong game version 1. I'm going to open that up. I'm going to run it. And we're going to see this Pong game version 1. There's no paddle here. There's no interaction. All we see is a ball moving over and back the screen. But you'll also notice that it can bounce off the top or the bottom as well. So we might see a bounce there. Yeah, just about. There's a bounce, so you can see it hit the bottom there and then bounces back up. So this is the only functionality we have to worry about. And given that we've already seen the spot class, there shouldn't be too much to implementing this. Okay. So let's take a look. We've got Pong game, and it's going to work with the ball. And the Pong game is responsible for setup and draw. These are the 2 methods that we've seen in all our programs to date. When we want to do an animated drawing, we must have setup and draw. So setup is going to call the ball constructor to create a ball object, similar to the way we previously created a spot object in earlier programs. And then the draw method is going to call the update and display methods in the ball class. And that's going to update the values in the ball and display them on the screen in the appropriate position. Just step back there for a second. We'll also notice that we have, let me get this working. Sorry, just one second. Let's get to here again. My tool has just left me down there. No, Doesn't want to play nice. Ah, okay, I see what's up. 2, 3. So we have some fields in our ball. And these are the fields. We have X coordinate and Y coordinate. Again, these are all common to what we did with the spot in earlier programs. And what's new is we've got 2 additional fields here for speed X and speed Y. And that's going to control how fast the ball moves across the screen. So these are some fields or properties of the ball class that we're going to be concerned with. Okay. So if we take a look, we have getters and setters for these fields, and we learnt in earlier classes that it's not acceptable to be able to change those fields from outside the class. So we define getters and setters for these fields. In order to do that, the fields need to be private. So you'll notice that we've got private here. All of these fields that we've declared, and they're all just floats. They've now got the private keyword in front of them, which means you can only see them and access them from within the ball class itself. So to be able to do that, we need getters and setters, and we have those here. We have get X coordinate, get Y coordinate, get the diameter, and we also have a set diameter, so that's the setter. So this is what our get methods look like. Nothing too difficult there. Get means return the value, tell us what it is, return it as a number. And you can see each one of those is just returning the actual field which we see here. So X coordinate goes to X coordinate, Y coordinate is returning the Y coordinate, and the diameter is returning the diameter. Okay. Set diameter does a little bit more. It's going to make sure that the diameter must be between 20 and then the height divided by 6. And this is just to make sure that we set a diameter that can be seen. So if the diameter is within that range, then we change the diameter to that value. If it's not, we give it an initialized value, and in this case we're setting that to be 20. If we look at the display method, this is the method that actually draws the ball. The ball is white, so because of that, we're saying that it's 255. Let me just change that for 1 second. Let's get the right tool here. Let's put that up. So this needs to be 255 to be white. There was no color around the ball, so it has no stroke. And we're drawing a circle, and we draw the circle by using the ellipse method, specifying the X and Y coordinates, and the width and height are both the same, which is the diameter field that we're going to use. So nothing too difficult there, it's all stuff we've seen before. Something new, so please make a note of this one, is that we have a private helper method called reset ball. And what a private helper method means is it can only be used inside the ball class. So it's only other methods within this class that can call it. And what we need to do to make that happen? Well, we're going to use the private keyword in front of the return type of the method. So the 2 methods that make use of reset ball are the ball constructor and the update method. So this is the bit that I'd like you to remember and make a note of. And a private helper method is private to the class you're in, i.e. you can't use it outside of the current class. And what makes that happen is putting this private keyword in front of your normal method definition. So this is called a private helper method. Now, inside of that private member method, we have one here called reset ball. And what reset ball is going to do is it's going to use some randomness. And randomness is what makes the game unpredictable. So it's never the same. Every time it runs differently each time. And that's because we're using some random numbers. So let's take a look at what's happening here. In resetting the ball, what we're saying is before the ball starts animating from left to right on the screen, we're going to we've got to set up the x and y coordinates and the speed at which it's going to travel. So the x coordinate is set to 0 because that's the left hand side of the screen. The y coordinate is set to some random height, and then speed x is random 3, 5, and speed y is random -2, 2. So we have two different ways of using the random method here. One is we pass in a single number, and the other way is we pass in two numbers. So here's a single number. It returns random float between 0 and high. And here's the second example, which returns a random float between the low number, inclusive, and the high number, exclusive. So effectively what that means is if you were to use -2, 2, then you might get back numbers -2, -1, 0 and 1, but 2 would not be included. Likewise, between 3 and 5, you'd get 3 and 4, but 5 wouldn't be included. Okay, let's just make sure you understand that. We're going to give you another question. So if you go to Socrative, please. And take a look at this answer. For any of you who couldn't get into the room, just mention it again. It's socrative.com and the room is C. Dunphy, as always. So the question is, what is the largest number that will be returned from random -2, 9? And it's based on what we've just been talking about random numbers. So I'll leave that up for help. And I think we're nearly all there. Let's see how we got on. Oh, brilliant. The whole class got it right. Hey, I'm doing something right. Well done, everybody. Okay. So let's move on. We're now going to look at the ball constructor. This is the method that gets called every time you create a new object. So what we're going to do is set the diameter and then call reset ball, which we've just looked at. So set diameter, we've already looked at. We take in a value and make sure that it's going to have a minimum value of 20 if it doesn't fit the criteria. And the private helper method reset ball is called to set up the x coordinate with 0 and the y coordinate, speed x and speed y, with random values. And we've looked at that in detail just a moment ago. Okay, so again, something that we picked up in earlier weeks was when we were drawing ellipses, we have the concept of the default ellipse mode is center. And this is going to be important. We're going to draw ellipses and rectangles, but their coordinate system is slightly different. And I just wanted to highlight what that's about. So when we say that the default ellipse mode is center, this means the x and y positions for the ellipse specify the center of the ellipse. So when we're trying to calculate where a circle is in terms of the screen, if we say that the width of the screen, and we were to draw a circle using the value of the width of the screen, the circle would be drawn as shown here. So you'd only actually see half of the circle. So at max width of the window, half the ellipse is seen, not the entire circle or ellipse. If we specify an x value that's greater than the width plus the radius of the circle has left the screen. So that's how we know that the ball has gone off the edge. And what happens when the ball goes off the edge? Answers please in Slack. So in Slack, So the question is, what happens when we go off the screen? What do we need to do? Can you reply please in the thread in Slack? Okay, so some interesting answers coming in there. I won't put Slack up on the screen because I don't want to share your names here. But some of the answers, let's take a look at them. The first one there was, we've lost a life. If the ball goes off the right hand side of the screen, absolutely, we've lost a life. We've also got the concept of losing a game. So that isn't the correct answer. You've only lost a life. You have 3 lives in a game. So that's something to bear in mind. Another answer, decrement the number of lives. Perfect. The private method to regenerate the ball is called with x equal to 0 and random y and speed values. So we had that reset method, reset ball. It was a private method, so that's where that's happening. You'd also need to decrement the number of lives though. Reset ball, good. Lose a life, also obviously. Lost life. Okay, you've all pretty much got the correct answer. So there's 2 elements. One is you've got to reset the ball. The other is the number of lives has gone down. And if the number of lives is going down, you're going to be checking, have we lost 3 lives? If we've lost 3 lives, we've lost a game. And then if you've lost 3 games, have you lost the tournament? Okay, so there's many layers in this game. Okay, good. Thanks for that. Well, let's switch back. Get you back to here. Right. So the point about what I was showing you here is, get myself out of the way, is that we were saying center means when you're drawing a circle, it's going to give you the x and y that you specify in drawing an ellipse, specifies the center of the circle. So the width of a screen, which goes all the way over to there, if you specify that as the x coordinate of the circle, it's going to draw it where the center of the circle is on the rightmost part of the screen, which means you only get half of the circle. Likewise, if you go beyond that, it's going to be completely off. So what we picked up here is if we can specify an x value greater than the width plus the radius of the circle, then the circle is going to be invisible. Okay, in other words, it's left the screen. So that's how we can check if the ball has gone off the screen. Okay, so let's take a look at the update method then. So there's quite a few components in here, but actually it's all simple logic that you've seen before. So let's take it bit by bit. We have update changes the ball position. So what that's doing is changing the x coordinate and the y coordinate to be whatever it is at the moment, plus whatever the speed value is. And the speed is just adding a number. So that's how we can change the speed of the ball moving by using a bigger number. We're adding a bigger number each time so it appears to move across the screen faster. Now, if the ball goes off the screen, we want to return true. And we can see in here, if x coordinate is greater than the width plus diameter divided by 2, reset the ball and the life lost is set to true. So that's what I was just asking you about in Slack. Okay, so you've all picked up on reset the ball and then you've got a life lost. If it hits the left edge, then we want to change the x coordinate direction. So the ball can move from left to right, but then it can go from right to left. So when it hits the left edge, we need to make it go back the way again. So what we're saying here is if the x coordinate is less than the diameter divided by 2, The x-coordinate is assigned a value, the diameter divided by 2, in other words the radius, and speed x equals speed x multiplied by minus 1. This minus 1 is important. When you multiply a number by minus 1, you're changing the sign. So instead of adding a number, you're subtracting a number. So that's how we get the change in direction, by constantly subtracting or adding the number. Finally, hit the top or bottom, we change the y-coordinate direction. Yeah, so this is how we implement our bounce. So we can see here, if the y-coordinate is greater than the height minus the diameter divided by 2, we set the y-coordinate to be the height minus the diameter divided by 2. And this is the important bit, speed y equals speed y times minus 1. So what you're doing is whatever direction you were going with speed, by multiplying it by minus 1, you're changing the direction. Likewise, when you get to the bottom, if the y-coordinate is less than diameter divided by 2, you're changing the direction again. Okay, so let's go into update again and maybe look at those individually, each of those cases. We've looked at 4 cases there. Let's go in and look at them individually so you can see it a bit more clearly. We have if x-coordinate is greater than the width plus diameter divided by 2. Just getting a question in here. Does the ball stay constant for the duration of each life? Yes. So when the ball comes on screen, the reset ball method is initialized to be a random number, and then that's the number that you use throughout until that ball disappears. So we're setting the speed up at the start, and the only thing that we do to the speed is change the direction, and that's by multiplying by minus 1. Okay. Thanks for that question. If x-coordinate is greater than the width plus the diameter divided by 2, diameter divided by 2 is another name for radius. So if the x-coordinate is greater than the width plus the width is the width of the screen plus the radius, then we reset the ball and the life lost is true. Okay, and we've looked at this one already. So it's what we were talking a moment ago when we were talking about the center of the ellipse. Once it goes beyond the width of the screen plus the radius, you know you've gone off the right hand side. If the ball hits the left edge of the display, the window display window, change the direction of the x-coordinate. So this is the picture that we've got. So we've the box here represents the screen. The ball has gone off the left hand edge. How do we check for that? We're saying if the x-coordinate of our circle is less than the radius, then the x-coordinate equals the radius and the speed x equals speed x multiplied by minus 1. So again, I might just do a little drawing here just to help with this. Okay, so if this box is our screen, this is 0, 0. This is the width. Sorry, I'm mixing up my tools. Okay, so width, so that's width is the x and the y is 0 there. You remember this from our earlier drawings. So this point down here is in 0 and it's down the height. And this point is the width, comma, height. Okay, so just our coordinate geometry, and because the ellipse is centered, the x and y coordinates specify the center, then we can say that in order for the circle to be completely off the left hand side, it needs to be at position minus the radius. So that's what this is checking. If the x coordinate is less than the radius, then the x coordinate equals the radius. We're putting it back into play. Okay, just got a cable after popping out. Let me just check that. There we go. We wouldn't like to lose you. Okay. So what we're doing is resetting the x-coordinate to the radius of the circle and reversing the speed x. Now what happens when we're bouncing? So this was the if statement to handle the bounce. So the first part handles when we hit the bottom of the screen, which we visualized here. So the ball has hit the bottom of the screen. We wanted to bounce back up the way. So again, what we're doing is changing the speed y value. And when we get to the top of the screen, which is the else if, we wanted to bounce back down the way. Again, we're changing the speed y value. The bit in the brackets is how we measure whether we're at the top or at the bottom of the screen. So we know we're at the top of the screen when the y coordinate is less than the radius. And we know we're at the bottom of the screen when the y coordinate is greater than the height minus the radius. Okay, one more method, the hit method. And what this is doing is changing the speed. So what's happening here is the ball hits the paddle. What do you want to happen? You want it to go back in the opposite direction. So when we have a hit, we're saying make the ball go in the opposite direction. So in that case, we're changing the speed x value. And then the x-coordinate equals the x-coordinate plus that speed x value, which is again going in the opposite direction multiplied by -1. So this is how we're handling the ball hitting the pallet and then rebounding back. So for the current version of Pong, we're not actually using this yet, but we will be using it shortly in version 3. This method changes the ball direction when it hits the paddle, bumps it back to the edge of the paddle. Okay, so let's take a look then at our Pong game. So we said we've got to create a ball object, so we declare ball. Then in our setup method, we're setting up the screen, in this case 600 by 600, turning off the cursor, and then we're creating a new instance of that ball object, initializing it to 20. Then in the draw method, we're changing the background to black, and then we're saying update the ball and update the display. And that's it. Okay, so that's version 1 of Pong. We've got the ball moving over and back. And let's move on to version 2. So with version 2, the mouse is controlled by the paddle. So what we want to have happen, and we have done programs in this already, is we've got our palette, and what we want to have happen is as we move our mouse up and down, we want that rectangle to move up and down with our mouse. If it goes beyond the bottom, we want to leave it in the bottom corner. If we go beyond the top, we want to leave it in the top corner. But we don't ever change the x and y value. It's only going up and down. Okay, so the mouse is going to be controlling the paddle. So again, what I'd like you to do at this stage is open up version 2, run it and see what's happening and test out and get the feel for running this version of the program. And then we'll take a look at what's involved in it and step you through it. Okay, so let's take a look. Again, I would encourage you all to be doing this yourself. Let's close that one off. And we'll open up version 2. And we'll run it. And you can see what's happening with this one. The ball is going up and down. Sorry, the ball is moving, and you can see as I move my mouse up and down, well, actually you can't see anything at the moment. Let's put it back in there. So hopefully you're running this yourself on your own computer. Thanks for the heads up, Kent. I've just switched it over there. You should be running this demo on your own computer from the zip file I supplied. It's version 2. And you can see that as we move the bat or the pallet paddle up and down. With the mouse, it's moving up and down. Okay, so that's fine. It doesn't rebound because we haven't implemented that code yet. We're doing this step by step. You'll notice that the ball goes right through the paddle. Okay, so that's all we're trying to implement. We're trying to implement moving this paddle up and down the screen. We're not interested in rebounding just yet. Okay, so I'm going to be very sneaky now. I'm going to see who's actually doing it. And I'd like you to post version 2 by taking a screenshot. And I'd like you to reply to version 2 with a screenshot of your demo running on your computer. By replying to the thread in Slack. So just take a screenshot and post it into Slack on the version 2 thread, please. Okay, so I don't want you to put a screenshot of me. I want to see you running it on your own screens, okay? I've got a distinctive background and file structure in my Finder, so I can recognize my own screen. Okay. Okay, thanks for that. Just want to get an idea who's actually running it, who's running it with me on and working through this on your own computer. So if you haven't been doing it up to now, when we're running the demos, try run the demo on your own computer. Okay, we've given you the files already. Okay, so version 2. So we have the ball, and this time we're introducing the paddle. So we're going to be creating a paddle object. So the setup is going to call constructors for both ball and paddle. Here's the ball constructor and here's the paddle constructor. Draw is then going to call update and display methods for both the ball and the paddle. So just like with the ball, the paddle class is going to have some private fields. They're made private, the X coordinate, Y coordinate, the paddle width and height. These fields are made private using the private keyword. Okay, again, stuff we covered in week 4 and 5. Because they're private, we then need to create methods to be able to access them. So we have the getters and setters for these private fields. So we've get X coordinate, get Y coordinate, get paddle width and height, and then set the paddle width and height. So here's our getters. And then we need to set the paddle width. So let's just take a look at this one. So again, nothing too difficult here. We're saying the paddle width must be between 10 and the width of the screen divided by 2. So we're not allowing you to create a paddle that's the full width of the screen. It's allowing you to specify a paddle width half the size of the screen. Otherwise, this.paddle width equals 20. So if you don't specify a value or it's outside the range, we're initializing it to be 20. Likewise for the height, we're putting some restrictions on what height you can specify for the paddle. So we just have an if statement checking if it's greater or equal to 50 and it's less than or equal to 2, then the value that you supplied becomes the new value for the paddle height. Otherwise, we just set it to 50. So we have a default of 50 in this case. Now, we don't always, in our setters, specify a default value, but in this case, it suits the program. So that's why we're doing it here. So back to our drawing modes again. We have rectangle. The default rectangle mode is corner. This means X and Y positions for the rectangle specify the top left-hand corner of the rectangle. So if we're drawing a rectangle and we specified the X value to be the width of the window, the rectangle that we're drawing would be invisible. Okay, so if we specify the width of the window as being the X coordinate for our rectangle, because the rectangle is in the top left hand corner, we wouldn't actually see the rectangle being drawn at all. That's what we're getting at. And this is different to the drawing mode for ellipse. The drawing mode for ellipse was center, you might recall, and the drawing mode for rectangle is corner. So if we specify an X value, which is the width of the screen minus the width of the rectangle, we could see the rectangle, or paddle in our case, being in its rightmost position on the screen, which is what we've indicated just here. So again, it's the width of the screen minus the width of the rectangle, so that we can draw this rectangle at its rightmost position. So we're going to be using that then in our various methods. Here's the paddle constructor that's called when you create a new paddle. We're saying set the X coordinate of the paddle to be the width minus this dot paddle width. In other words, it's the width of the screen minus the width of the paddle that we're trying to draw. This refers to the paddle width. That's a field or property of this class. And the Y coordinate equals whatever the height of the screen is divided by 2. So we're basically putting it in the center of the screen, more or less. So then we can display our paddle. Our paddle is a grey paddle, so hence the 102. It doesn't have any stroke because there's no border around it. And we just draw a rectangle using the X and Y coordinate, the paddle width and the paddle height, all specified in the private member fields. So this draws a grey paddle with no outline on the display window. So then on to our update. So update is going to be called within the draw method. It gets called 60 times a second, you might recall. So we have the Y coordinate equals mouse Y minus the paddle height divided by 2. Reset the Y coordinate if it's outside the window coordinates. So if the Y coordinate is less than 0, in other words, if the mouse pointer has gone off the top of the screen, okay, if this is our screen and the mouse pointer goes off the top, then the Y coordinate of the paddle is going to be 0. Then the second if statement is checking if the Y coordinate has gone off the bottom of the screen. Then we're saying it's gone off the bottom, so therefore we want to draw the paddle at its bottommost position, which is the height minus the paddle height. So this update is how we change the vertical position of the paddle in line with the cursor. So here's the finished program. What's new? We have a ball as before. We've added the paddle object, and then we've created a new paddle. And in addition to updating the ball and displaying it, we're now also updating the paddle and displaying it. So we're creating ball and paddle objects, and we're calling their update and display methods in the draw method. Okay, so that's version 2. I'm going to switch you back to Socrative now. I've got another question for you. based on some materials we've just covered. First question is, the default ellipse mode is center. True or false? Okay, thank you for your answers. Let's take a look. Not everybody got it right. So the default ellipse mode is center. That's a statement with a question mark on it. Is it true or is it false? So the ellipse is the circle. So the circle, we were specifying the center of the circle, and all our logic then is based on taking that into consideration. So the answer there is actually, it is true. Okay, so the correct answer there is true. So I think everyone bar one got it right. Hopefully if you got that wrong, you understand why now. Let's try one more. The default rect mode is center. So the previous question was the default ellipse mode. This is the default rect mode for rectangle. When we're drawing rectangles, what's the default? So you don't have to tell me what it is, you just need to let me know, is it center or not? True or false? Okay, all answers in. Let's take a look. One person getting it wrong again, but everybody else is right. Let's explain why. The default mode for the rectangle is corner. Okay. So I'm just going to switch back to here for a second. And let's try just go back over that because it is causing some trouble for one or two of you. So if we're drawing a circle or an ellipse, what we're saying is this point here is where when we specify the X and the Y, okay, that's center mode. When we're drawing a rectangle, which we did when we were drawing the paddle, what we're saying is we're in corner mode. And what we mean by that is when we specify the XY, you're specifying the X and Y of the top left hand corner. Okay. Now it's important that you get this concept because all of the logic in the if statements are taking account of the size of the circle, the ball, or the size of the paddle, which is the rectangle. And it's taking account of where the X and Y and the width and the height is in relation to this point in relation to the screen. So it's important that you get this concept so that it will help you to understand why the statements are the way they are. Okay, center and corner. Okay, I'm going to stop there for a little breather. I think we'll have our convenience break now. We're running a little bit over, but we've done a lot of activities in today's class, so I don't mind if you don't. Right, let's turn on a timer. Let's give ourselves 6 minutes. And let's start that off. And I'll turn off the mic for the next 6 minutes. If you have any questions, if any of you are still having trouble with that center and corner, maybe just let me know about it on Slack. Otherwise, we'll see you in 6 minutes. Okay, everybody, welcome back after that short break. I remembered to turn my microphone back on, just about. Okay, let's switch to here. So, before the break, we looked at 2 versions of Pong. We're now going to have a look at some more. Version 3. In this version, we are going to investigate how we do collision detection. In other words, when the ball bounces back from hitting the paddle, how does it bounce back? Changes are made only to the Pong game. So again, I would encourage you now to open up on your computer from the zip file that you've unzipped at the start of class, version 3, and run it so you can see it in action. Let's take a look here. Let's get to here. Okay. So we want version 3. Here's version 3. And we're going to run it. And we'll bring that across so you can see it. Okay. So what we see in this version is the ball is moving across the screen as before, left to right. It's bouncing off the bottom. And our paddle is now in play, and when we move our mouse pointer up and down, the paddle goes up and down. Previously the ball went through the paddle, and now what we're handling is it identifies when it hits the paddle and then bounces back. Okay, so we haven't gotten into any scoring or anything yet. We're just watching how the ball hits the paddle and rebounds back. That's the code we're trying to implement with this version. Okay, so let's take a look at that. So version 3, we've got in the Pong game, we have our setup and draw methods that are making use of a ball and paddle objects. And now we're going to introduce the notion of hit paddle. This is a new method called hit paddle, which makes use of the paddle and the ball. So the ball and paddle classes, there's no change to them. We've already set up all the methods that we're going to be using. We're just going to create this new method called hit paddle, which is in the Pong game for collision detection. So draw is updated to call the new hit paddle method. Hit paddle uses a collision detection algorithm. If the paddle and the ball are touching, it returns true, otherwise it returns false. So our method signature is Boolean, so it returns true or false. Hit paddle is the name of the method, and it takes in a paddle object and it takes in a ball object. So there's 4 steps to this. The first thing we've got to do is measure the size of the gap between the paddle and the ball. If the ball is too far away from the paddle on the x-axis to have a collision, we return false. If it's too far away from the paddle on the y-axis to have a collision, we return false. Otherwise, we return true. So we rule out, we look at the scenarios where we know it definitely can't be a collision. And if it's none of those situations, then we have a collision. That's the logic. And how do you do that? The first step is you have to measure the gap between the paddle and the ball. So that becomes our next issue. So I'd like you to make a note that there are 4 parts to this algorithm. 1, 2, 3, and 4. Okay, 4 parts. And we're going to see that then a little bit later when we see the full solution to hit paddle. So the first thing we're going to look at is measuring the gap between the paddle and the ball. So we have a default ellipse mode of center. This means the X and Y positions for ellipse specify the center of the ellipse. We've already gone through that in detail today. We also learned about the rectangle being the corner method. We went through that just before the break. So when we come to measure the size of the gap between the paddle and the ball, we have a formula. It's the distance for if we look at the y distance, it's sorry, I've jumped ahead there. We need to first calculate how far away the ball is from the paddle on both the X and the Y axis. So we have two variables here, circle distance Y and circle distance X. And I've color coded them just to help you follow along a bit easier. So here we have the paddle in grey, the ball is in white, and taking account of the drawing mode for both circle and rectangle, we know what the X and the Y values refer to. So the circle distance Y and the circle distance X are shown here. Here's another example, and another example. So these are different scenarios. For example, here we actually have a collision. Here we can't possibly have a collision. Here we can't possibly have a collision. Here we can't possibly have a collision. So let's take a look at hit paddle. Measure the size of the gap between the paddle and the ball. So we're calculating the circle distance X. So the circle distance X is described as ABS, as that stands for absolute. The absolute value just means ignore the sign. So we have the absolute value of the ball dot get X coordinate minus paddle dot X coordinate. So you're subtracting the X coordinates from both. Get the absolute value of that. The circle distance Y is calculated as the absolute value of the ball Y coordinate minus the paddle Y coordinate minus half the paddle height. So we have two formulas for calculating the distance between the circle and the paddle for the X and the Y. So what is the circle distance X if the circle is at 200, 400 and the paddle is at 380, 100 with a paddle height of 100? And I'm going to ask you to answer that in Socrative, please. To help you out, I think what we'll do is I'll show you, this is where you're answering, and to help you out I'll just show the previous slide with the formulas on it. Okay, so all you have to do is plug in the numbers and see what values you get back. So our first question is, what is the circle distance X if the ball is at 200, 400 and the paddle is at 380, 100 with a paddle height of 100? So what you want to do is plug in what you know. You have a formula here. And from the question, you should be able to figure out what these values are. So we're looking for the ball.x coordinate. And it tells you it's at 200, 400. So the x coordinate is going to be 200. And it also says that the paddle is at 380, 100. So the x always comes first. And in this case, the paddle is at 380. So it's 200 minus 380, which is going to give you minus 180. Now the abs bit, absolute, basically is around all of this. So the absolute of minus 180 is just 180. Okay. So obviously that's causing a bit of bother because being a bit slow on the uptake in Socrative. Let's take a look. So 5 or 6 of you got the answer. So hopefully at this stage you understand x and y coordinates. X comes first, y comes second. And all we're doing is plugging these numbers into the formula that we had on the previous screen, which was here. Okay, let's see how you got on with the answers. So the 180 is perfectly fine. We only asked for circle distance x, so you'd only be calculating and only giving me back one number. Okay, and I've shown how to calculate it there on the screen as well. Okay, cool. Let's give you one more. You know what's coming next. You calculated the circle distance x. Now I want you to calculate the circle distance y. Okay, and to help, I'll just put this screen back up. And what we want you to do again is just to work your way through this formula and plug in the numbers and see what you come up with. Okay, so what have we got here? We've got ball.y coordinate, and our y coordinate for the ball was 400. So you'll plug 400 in there. You are subtracting the paddle, which was 380, 100, so that's 100 for the y. Minus the paddle dot get paddle height. We said the height was 100. Divided by 2. And the division will be carried out before the addition and subtraction. So we get 400 minus 100 minus 50. So that's 400 minus 150, which is 250. So let's see how you got on over in Socrative. Okay, show the answers. Great stuff. Okay, maybe I'm going a bit too slow. Well done though if you got that. Okay, that means you're following what's going on and how this program is working. Okay, well done. Okay, so let's get back to here. So we've done those two questions and we've implemented it in the quiz. Next thing to do is to check if the ball is too far away from the paddle on the x-axis to have a collision. Here's how we do that. We check if the circle distance x is greater than the ball dot get diameter divided by 2. If it is, we return false. Next we check if the ball is too far away from the paddle on the y-axis to have a collision. If the circle y is greater than the paddle height divided by 2 plus the ball.getDiameter divided by 2, then we return false. And finally, if it's not false, then we return true. In other words, we have a collision. And I've shown pictures to represent what might be happening. So here we have the x coordinates are close enough, and here we have the y coordinates are close enough. So when we put those 4 cases, we had to, again, remember, measure the distances, get the circle distance x and y, then check if the circle distance x is the right size, check the circle distance y, otherwise we have a collision. So we're returning true or false from this hit paddle method, and that's why we're saying return true here, return false, return false. So we call the hit paddle method from the draw method in our Pong game class, which in turn calls ball.hit if it's true. So we're saying if we have a collision, call ball.hit, and what that does is make the ball bounce back in the opposite direction, and it does that by changing the speed by multiplying by -1. And that is game version 3. Now, I took my time going through these versions and got a couple of minutes left. I'm not going to try race through versions 4 and 5. As you can see, you need time to test out the demo, take a look at the slides, watch the video, see what's going on before you move on. And everybody's going to be doing that at a different speed. So this week's classes don't actually suit giving a lecture and trying to cover all the material for the week as one big lecture, because nobody would be able to keep up. So what I've done this in today's class is we've gone through 3 versions of Pong. There is version 4, 5, 6, 7, 8 and 9 still to do. I'll make some talks for version 4 and 5, but you have the sample code, you have the slides. I'm quite happy to make 2 additional videos for versions 4 and 5, and I've already released versions 6, 7, 8 and 9. So what I want you to do is to go through each of these. I'm just going to bring up something here. What I'd like you to do is I'd like you to go through in your own time this week. We're going to be effectively flipping the classroom. So we've gone through versions 1, versions 2 and version 3. What I need you to do is to go through version 4 and 5 in your own time. And what you should be doing is running the labs after each one. Okay, so you can see the labs for each version, taking you through the steps in order to implement this and build it up yourself. So there's no advantage to saying I have the final version of the program running. The advantage is that you can work your way through each of these codes. So effectively what we're doing is we're going to be flipping, if you like, the classroom for this week. Rather than me giving you a lecture, we're going to be asking you to work through the materials, and I've set them up nicely for you for each version. So you'll see here's version 6. So this will show you a demo of the program running and what to be looking out for. Then in here we'll see the talk, what would normally come in a lecture, the slides to go with that version of the program, and then the lab are the individual steps that you need to take in order to implement and code it yourself. So what I'm asking you to do is to watch the demo, review the slides in the video, and then complete the lab. The running time for the videos is 1 hour. So you'll do that for version 6, 7, 8 and 9. You can leave 9 out if you don't have time, but definitely the first 8 you need to have completed by the end of the week. Okay, so just to recap on today, what we've done is we've looked at the game of Pong. We've identified all the different problems that are in programming games, and we're stepping our way through each of those problems to show you how to solve them and write the code for them. And the purpose of doing this is at the end of the week, you will have been able to write your own game, and then the assignment, the specification, which will go out next week, will be to write your own game, and you'll use all these ideas in your own game. So you can start thinking about that. Okay, so that's the end of today's class. As always, if you have any questions, please post them on the programming channel in Slack. And I did mention one thing, and that is that we are going to be reducing the frequency that we respond to direct messages, because most of the direct messages that we're getting really should be on the public channel in programming. And it's important that you, after 6 weeks now, you should be well able and confident enough to ask questions of each other and to help answer each other's questions. So we're going to be reducing the amount of one-on-one that we're giving people, because the class is just too large to be doing one-on-one questions with everyone every single day. Okay. So question just popped up there. Is there a class on Wednesday? There won't be a live class on Wednesday because I've already produce the materials for it, and what I'm saying to you is you can go through it in your own time at your own pace, and the way I want you to do the class is I want you to do it at your own time. I want you to watch the demo for a version, go through the slides or video, and then implement the lab, and by doing it that way it makes more sense than trying to squash all of the materials into a lecture and then try to do all the labs in one go. I think you'll find it this will work a lot better, particularly for the content that we're covering this week. Okay, so and we'll ask you how you feel about that maybe at the end of the week. Okay, so last thing today then, I'm just going to launch an exit ticket. The question is, which element do you think that we covered today is going to be most important to you in building your own game next week? Okay, which element that we covered in today's class do you think is going to be the most important when it comes to writing your own game? Okay, so I've just turned on the exit poll, please, and I wouldn't mind if you would do that. And thanks very much for class, and enjoy the rest of the week. And if there's any issues, you know where to find us. Thank you.